Okay, so let's continue this story here so we can ease into the concept of turning a molecular formula unit equation into a complete total ionic equation and then into a net ionic equation. Just to quickly recap, you're going to need this information. You're going to need the solubility rules that you will eventually memorize, okay? You're also going to need to remember these strong acids. Remember, they're hydrochloric, hydrobromic, hydroiodic, sulfuric, nitric, and perchloric acids. Those are your strong acids. And you have to remember the strong soluble bases, group 1A metal hydroxides, and then the heavy group 2A, which are calcium hydroxide, strontium hydroxide, and barium hydroxide. Okay, so the equations that you've normally been given are called molecular equations, or sometimes they call them formula unit equations. This is the reactant side of the molecular formula unit equation. What would the product side be? Do you guys remember double replacement reactions from intro chem class? Well, we're going to have to know them in this chapter. Those double replacement are called metathesis reactions or exchange reactions. Remember how you change partners? Cation of one substance hooks up with the anion of the other substance, sort of like, square dancing and all that. So cation, anion, cation, anion. So remember from intro chem days, A, B, C, D. Remember how A hooks up with D and then C hooks up with B. So let's create the other side here. Potassium will hook up with nitrate. Potassium's +1, nitrate is -1. This is an easy one. We just go KNO3. And then silver hooks up with chloride. Silver is +1, chloride is -1. So again, really easy. And this one is actually balanced, and we don't need to add in any coefficients because everything's 1 to 1 to 1. Okay, perfect. So this here is an example of a molecular or formula unit equation. Good. Now we want to turn that into a complete or total ionic equation. How do you do that? You break apart anything that is a strong electrolyte. Okay, so is potassium chloride a strong electrolyte? Yes, because it's a soluble ionic salt, because this has a group 1A in it. And remember how we said all group 1A are always soluble. And if you don't believe me, go look at your solubility rules and you'll remember that. All right, so let's break this apart. So we go K plus aqueous plus Cl minus aqueous, just like we did at the end of the last video. All right, now silver nitrate. Is silver nitrate a strong electrolyte? Well, it's a salt. Is it a soluble ionic salt? Yes, because all nitrates, remember, are soluble. So we're going to break this guy apart too. So Hg plus aqueous plus NO3 minus aqueous. Okay, now we go over to the other side. Potassium nitrate. Is potassium nitrate a strong electrolyte? Yes, because it's got a group 1A in it and it's got a nitrate super soluble, so we break that apart. K plus aqueous plus NO3 minus aqueous. Okay, now what about silver chloride? Agcl. Remember the rule that said all chlorides are soluble unless they're hooked up to silver, mercury, lead? So if you look at that rule, the solubility rules, silver chloride is insoluble. So remember what I told you guys in the last video, you write an S. Agcl is an S, solid. It's a precipitate. Okay, so this is an example of a complete ionic, or in some books they call it a total ionic equation. So you turned the molecular or formula unit equation into a complete ionic equation. Now to turn that into a net ionic equation, you cancel out all the spectator ions. What are spectator ions? Those are the ions that look exactly the same on both sides of the equation. So see this potassium here? Maybe I'll use a blue pen. This potassium here will cancel out with this potassium here. Identical, all right? This nitrate here will cancel out with this nitrate here. Now, the silver chloride is intact, so it can't cancel out with these silver ions and chloride ions. So once you've canceled out the spectator ions, whatever is left is your net ionic equation. So I'm just going to rearrange it because I always like to put the cation before the anion. If you don't, and on this side, it's not a big deal. I'm going to write Ag plus Aq plus Cl minus Aq will give you AgCl solid. This is your net ionic equation. You turned this equation into this, and then this, after you canceled out all the spectator ions, into this. How did we do it? We knew our solubility rules. We knew which ones were strong electrolytes and which ones were not. And the ones that are strong electrolytes, you break them apart into ions. The ones that are not strong electrolytes, you keep them intact. Okay, so let's move on to this one over here. Same scenario, metathesis reaction. The H is going to hook up with the OH to form water. The magnesium is going to hook up with the sulfate. So we're going to write MgSO4 plus water. Okay. Let's balance it. You have 2 hydrogens, 2 hydroxides, so you have 2 waters. Now it's perfectly balanced. Okay, let's turn this into a complete or total ionic equation. Is sulfuric acid one of the 6 strong acids? Yes. So let's break it apart. 2H plus Aq plus SO4 2 minus Aq. Where did I get the 2H plus? Here, I have 2 hydrogen ions here. So 2 H pluses and 1 sulfate. Okay? Now, magnesium hydroxide is a base. Why do I know it's a base? Because it's got a hydroxide in it. But is it one of the strong soluble bases? Is it a heavy group 1A? Is it a group 1A metal hydroxide? No, magnesium is a group 2A. Is it a heavy group 2A hydroxide? Well, in order for it to be considered heavy, it has to be calcium or heavier. So nope. What do we do with the magnesium hydroxide? We leave it intact. You do not break it apart. So we're going to write MgOH2 solid. All right? Leaving that alone. Okay, now we go over to this side. Magnesium sulfate. Remember the solubility rule that says sulfates are all soluble unless they're hooked up to silver, mercury, lead, or calcium, strontium, barium. Okay, well, this is magnesium. It's not calcium, strontium, barium. It's not silver, mercury, lead. So it's soluble. So we break it apart. Magnesium 2 plus SO4 2 minus. Okay, and then the last one is water. Water is not considered a strong electrolyte. It's not a strong acid. It's not a strong soluble base. And it's not a soluble ionic salt. So we leave that alone. 2H2O. But and then we just write liquid. It's a pure liquid. Okay. All right. Now what? What can we cancel? Well, the only thing you can cancel is the sulfate. So we're going to cancel this and cancel this and then rewrite it. 2H plus aqueous. What are the sulfates? The sulfate is the spectator ion. 2H plus aqueous plus the magnesium hydroxide solid will give you magnesium 2 plus H2O, let's see, aqueous, sorry, H2O liquid. There you go. If you still don't know your polyatomic ions and you're still struggling to know your elements and you don't know anything about the language of chemistry, you're going to have a really hard time with chapter 4. So I highly, highly recommend you go back and review all the key language of chemistry so that you can start doing really well with all of this. All right, let's do a few more. Okay, here is another one. Oh, and by the way, anytime you have a solid as a product, that's called a precipitation reaction. Okay, so here is another one. Potassium phosphate plus calcium chloride. Okay, we're going to see if that is a precipitation reaction or not. All right, so potassium phosphate plus calcium chloride. It helps if you know how to write your formulas, guys, plus calcium chloride. Okay, now, metathesis reaction or double replacement or exchange. What are we going to do? Cation hooks up with anion. Cation hooks up with anion. All right, potassium's +1, chloride is -1. They come together, KCl. Cation is calcium. Phosphate is the anion. Calcium's +2, phosphate's -3. So Ca3PO4 2. Okay, so that is the equation. We now have to balance it. I've got 2 phosphates over here. Let me put a 2 over here. I've got 3 calciums over here. Let me put a 3 over here. So I've got 6 potassiums and 6 chlorides. Let's put a 6 over here. Looks super cluttered, but we'll have to make do. 6 over here. Okay, guys? All right, so now I have my equation. This is my molecular equation, and now I want to turn it into a complete ionic equation. And what are you going to do? You're going to break apart anything that is considered a strong electrolyte. Remember, this is a group 1A. So group 1A, always break it apart. It's a strong soluble, it's a soluble salt, so it's a strong electrolyte. So we're going to write 6K plus. I'm going to not put all the aqueuses because they clutter up everything. So bear with me. 6K plus 2PO4 3 minus. Okay? Plus calcium chloride. Chlorides, we said, are all soluble unless they're hooked up to silver, mercury, lead. So the calcium is fine. So we're going to write plus 3Ca2 plus 6Cl minus. Why am I doing 6Cl minus? Because I have 6. 3 times 2 is 6. Okay, good. I got this side fine. Now, potassium chloride, group 1A, definitely break it apart. It's a soluble salt. It's a strong electrolyte. So 6K plus 6Cl minus. Now, calcium phosphate. Phosphates are very insoluble. The only exceptions to the insolubility of phosphates are if the phosphates are hooked up to a group 1A. Well, calcium is not group 1A, so this is plus Ca3PO4 solid. This is a solid. So if the question is this a precipitation reaction? Absolutely, it is a precipitation reaction. You get calcium phosphate as a precipitate. How do you turn this equation into net ionic? You cancel the spectator ions. Let's use the blue. Which ones are the spectator ions? Well, anything that appears exactly the same on both sides. The 6 potassiums, 6 chlorides, 6 chlorides. So you rewrite it, and your final net ionic equation, I'm just going to put the cation before the anion, 3 calcium 2 plus aqueous plus 2 phosphate 3 minus aqueous will give you Ca3PO4 2 solid. There's your net ionic equation. Okay, so the only way to get really, really, really good at this is to just keep practicing. You need to know your solubility guidelines. You need to know which ones are the strong acids, because all other acids are going to be considered weak. So if I throw in a sulfurous acid or a chlorous acid, those are weak acids. Don't break those guys apart. Only break apart the strong acids, strong soluble bases, and the soluble ionic salts. Okay, so next video we will do a different topic.